Buongiorno, I am Andrea Bassi, sales manager in glass service, the one located in Italy. And together, me and my colleague will introduce something about the system to reduce the CO2 emissions. I will talk personally about the oxy-gas combustion. Both solutions come from a real necessity, an emergency, we can say, for what concerns the gas consumption and the CO2 emissions that have high level in this last period. So we are in what we can call an emergency situation. The glass industry itself, but in general, all the industry needs to review the way we make production, and in this case, the way we produce glass. Decarbonization is the word that today you know, of course, and there we have two very ambitious targets. One is in 2030 to reduce the CO2 emissions of 80%. The other one, very, very ambitious, is to become net zero carbon in 2050. Glass service, so from what is a problem, started to develop, study, and deliver to its customer this product, so found an opportunity on this with the oxy-gas combustion and with electric Forehearths. The oxy-gas combustion is basically consists in an easy chemical reaction where the air is replaced by the oxygen. So you don't waste energy to heat the nitrogen that is present in a big percentage, 78. With this process, we have three main advantages. The consumption of gas reduced up to 60%. We almost have no NOx, and the emissions of CO2 are reduced by 60%, at the maximum of 60%. At the same time, we have we maintain the same quality standards, because at the end, the customer wants the quality of the glass he produces. So we have efficiency, we have process stability, and I will tell you why, and we have glass thermal homogeneity. All these mean glass quality. Just to talk a bit more technical, I will show you how our systems are composed. We have a first skid of pressure reduction and safety for oxy and gas, and then we have a single control skid. I mean, we can control independently the flow in any Forehearths and in any zone of our Forehearths. In this picture, we have just a more graphic configurations. Of course, any skid contains the main devices for regulation, safety, and the dedicated control system. They are just showing pictures to make you understand better what I'm talking about. This is a rendering of a real Forehearths that we delivered in the last months for our Indian customer. Just to say that this process is applicable to any kind or any type of glass, and for any type of glass we can maintain the same quality requirements. Look, this is the burners that we use in the Forehearths. They are easy to install, maintain, and the main characteristic is the low power. They go from 1.5 to 5 kilowatts, and in the main Forehearths, in all the lengths of the Forehearths, you have a lot of quantity of these low power burners. Why? Because in this way you can have the thermal homogeneity that you need to get the best quality of the glass. We designed these burners with computational fluid dynamics, where we can simulate the shape and the length of the flame. But one nice characteristic is we can remove the carbon deposits on the nozzle. So we have a clear nozzle and good performance of the burner itself. The nice picture is good, is nice. Look, in the drawing, you have the simulation by the computational method. Below, you have the real picture taken from a camera inside the furnace. As you can see, the flame is completely the same as we simulate by the computational method. And first of all, he doesn't attack the surface of the block, of the burner block. Now, I wanna tell you some numbers, because at the end is what matters to our customers. They want quality, they want to make production, but you know, they want to make money at the end. Here I took one standard Forehearths, K36 width, 3 zones, 8 meters. Approximately, we have 130 low power burners, as I showed before. Please consider these numbers like an idea of what you can get and what you can save. There is the comparison between the standard combustion air gas against the oxy-gas. Considering the mentioned Forehearths and the cost of the gas, we have approximately in a year a cost of 100,000. Using oxygen, we save. I put 55. So just to be more realistic, the consumption of gas is reduced until 15. The consumption of oxygen is double, as you saw in the reaction. There is a mistake. It's not a euro, it's a quantity of gas per hour. The cost of the oxygen approximately is 0.1 euro, and we have 70,000 euro of cost in 1 year. So just now we save approximately 30,000 euro. In some countries, we need to consider the cost for every tons of CO2 that is emitted. With these quantities, I considered 25 kilo euros that it needs to be considered an additional saving in some countries. So, with this process, we are approximately at 55,000 euros. This is for the process, for the operation. But we have an additional cost for the structure because there is the reduction skid that is more expensive. We have different devices, different regulation, independent regulation for every Forehearths. So the cost is higher. I just say that we calculated this in 65–66%. So considering the comparison with what you save, with this process, you have a payback in 15 months, 15–16 months. So we can consider this as a success because there are no other solution that can give you this payback in so few time. Okay, this is you could say this is theory. In the last months, we delivered one Forehearths with we converted one Forehearths to the Oxy-Gas Combustion for an Indian customer. They are producing 45 tons per day. and with the filtered glass, and they recognize that there is this advantage. They also calculated with the Owen-Illinois method efficiency of 97%. That is fantastic, I think. In the next picture, just to show you the working temperature of this process and the homogeneity of the temperature in the distributor and in the first part of the Forehearths. So this was the first product for the CO2 emissions. Now I'll leave you the time to my colleague. Thank you.